Exercise 2026 is just trying to get you to see possible ketones. So if you have an acetal or if you have an imine, you can use a little bit of acid to either do hydrolysis of the acetal to get back the ketone or hydrolysis of the imine to get back the ketone. And so here, you don't have to draw the mechanisms, you just have to predict the ketone. What ketone can you make, for example, out of this top molecule? Well, look for the acetal carbon, the carbon that has the ether bonded to it on both sides. So that's this orange one right here, and that's the one that used to have the ketone. So you want to draw the carbon chain that has that carbon on it, redraw that, and then that carbon, this one right here, that's the carbon that would have the carbonyl, so double bond to an oxygen. So cyclopentanone. So that would be the one product, and then the other product is going to be the diol, the molecule with the two alcohols. So that will be this other half that we didn't draw. So notice that has 1, 2, 3 carbons. So 1, 2, 3, and then the OH coming off of the two ends. Right, we have the oxygens there, and when you hydrolyze it, you get the two alcohols that you need to form that acetal. So these would be your molecules, the molecules you'd get if you took this weird ring-looking thing and you treated it with some acid. So B is a similar idea. You're breaking apart an imine, right? An imine is that nitrogen equivalent of a carbonyl. So you can draw the part of the molecule that has the carbonyl on it, carbonyl carbon. You can redraw that and have the double bond. Instead of going to the nitrogen, it'll go to a oxygen. And then for the nitrogen, for that part of the molecule, you can redraw that separately. And the two bonds that you're missing, oops, so you'll still have that methyl group here. But the two bonds that were going to the double bond, those now go to two different hydrogens. Right? Remember, you need a primary amine in order to make an imine. And so you can see this is a primary amine. It's only bonded to one carbon. And it's the loss of those two hydrogens that allows that nitrogen to form the double bond of the imine. So those are your two products. You'd have 2-pentanone and methylamine. Okay, this last one looks a little tricky, but you want to look for the carbon that has two ethers connected to it. And that is this carbon up here. So that carbon has an ether on one side and an ether on the other, oxygens that have carbons on both sides. It's that carbon in the middle that is going to be the carbonyl carbon. Now notice that's all by itself. So if you take that and you put that carbon all by itself, you replace it has the two hydrogens there, but you replace the bonds to the ethers of the acetal with a ketone, you end up getting formaldehyde. The simplest, smallest aldehyde. So that's that. And then the rest of this is going to go to form the diol. So you can just redraw that same exact structure. So the oxygen going down over oxygen, the methyl groups. So the same exact structure as that purple thing. You just want to have hydrogens on those oxygens because they end up being alcohols. Now it's kind of a funny way to draw things. If you wanted to draw it maybe more conventionally, you could number this. So 1, 2, 3. So you could have 1, 2, 3. And off of carbon 1, you want 2 methyl groups and an OH. And off of carbon 3, you want 2 methyl groups and an OH. It really doesn't look that different, and I wouldn't take any points at all if you drew this, which is perfectly correct. You would want both of those as your products. I just wanted to show you how you can take something that maybe looks a little less familiar and draw it in a way that they might give you on a multiple choice answer on a standardized test by numbering things. Okay, so this is just getting you to training your eyes to see hidden carbonyls. Either whenever you see an acetal, think, I could turn that into a carbonyl. And whenever you see an imine, think, I could turn that into a carbonyl. all I would need in both cases is a little bit of acid.